Hi everyone, my name's Casey Anderson. I'm a program manager on the Visual Studio debugger team. And today I showed up here to show you how to supercharge your debugging in Visual Studio. So on the agenda today is 20 plus tips and tricks for Visual Studio. We want to show you these tips and tricks because no one teaches us how to debug. Oftentimes we get paid to write new features and fix issues, but no one teaches us how to use the tools available to us. So today in Visual Studio, that's what I'm hoping to do for you. I'll be demoing some new stuff from Visual Studio 2017, and I'll make sure to call out what exactly is new in 2017. And the rest of it will be coming from previous versions of Visual Studio. So even if you haven't upgraded yet, but I encourage you to, you'll still get some goodness from this as well. And then after those tips and tricks go by, at the very end, I'll try to show you a sneak peek at a feature coming soon that I'm sure will entice you to stick around. And finally, I have a special guest here with me that is going to show us debugging in production. So let's get started. Okay. Jump into my demo here in Visual Studio. So this is just Visual Studio 2017 open up. I'm going to start debugging. I'm working with my coworkers on this app. We need a night job. So we're making a shuttle app trying to compete with Uber. Just kidding, we're not competing with Uber. So right here, I've got my app running in the browser. I've got a list of vehicles here and a list of drivers that's supposed to show up. So my driver actually isn't showing up. It's kind of a blank image here. Let's see if that's just a one-off or if that happens every time. Well, it happened on that one and that one too. So something's going on and I've got to go debug this issue. Well, the first thing I want to talk about is this diagnostic tools window over here to the side of my screen. From my observations, the diagnostic tools window was available in 2015 of Visual Studio, but a lot of people have closed it since then. They haven't really seen the value that this awesome window can provide. So I'm going to show you how you can really take advantage of this window and what it's capable of. Right here, right now, as I am selecting these different drivers, because I have the diagnostic tools window open in the background, I can see that exceptions are being thrown, as indicated by these diamond markers in this events track. And every time I click a button, another exception event is being thrown. Well, one of the reasons I can see this is because I have my diagnostic tools window open and it's really small. That's a new addition to Visual Studio 2017. We added this convenient summary page, so I can keep the diagnostic tools window even smaller than my Solution Explorer and still be able to see the memory and CPU graphs ticking away, as well as an overview of what events are happening in my application. Like I said, I'm looking at exception events happening. So let me go over to the Events tab, and now that I want to investigate, I can make this bigger and read some of these details. Right here, it's in red, and it's showing me that an exception's being thrown. The reason I'm able to view this information is because I have Visual Studio Enterprise, and I have IntelliTrace enabled. IntelliTrace is the feature that is recording all of these output events and exception events and different events that are happening in my application. When I click on an exception, you can see it expands the details there and it tells me more information about it. It also shows me this link on the bottom that says Activate Historical Debugging. This is, like I said, an IntelliTrace feature, and when I click on this link or double click on that event, it's going to throw me back in time to the place in code where a particular event happened. So right here, you can see highlighted in this salmon pink color, and by this yellow bar, it tells me that I'm in historical debugging mode. So I'm no longer quote unquote live debugging. I'm back in time at this line of code. And it's telling me, oh, your exception happened here. So without needing to restart the application or even reproduce the issue, I'm able to find that point in code because of what IntelliTrace gives me. And I never would have seen that had I not had the diagnostic tools window open. So because IntelliTrace is an enterprise feature, don't worry, we do have a way for you to be able to figure out where this exception is happening, even when you don't have IntelliTrace. in this exception situation. So I'm going to go ahead and go to I'm going to return to live debugging first. So I'm going to hit continue to get back to where my app is responsive. I'm going to go to a window we call the exception settings window. And this window is like, you can think about it like turning on breakpoints for particular exceptions. We've got common language runtime exceptions, which are your .NET exceptions. So we also have C++, JavaScript runtime exceptions, things like that in here. I'm going to go ahead and click this box and get a check mark there. This is indicating to the debugger that I want to break when these exceptions are being thrown. Because I knew from IntelliTrace this was a null reference exception, I could also search in here for, null reference and just mark that one exception. But I'm going to go ahead and leave them all on. Now, in the list, it's a default list of exceptions that we have for you. So if you have exceptions that you want to specifically turn on, you can go ahead and add these to this list here to configure those exception style breakpoints. Okay, so now that I have this turned on, I have to go back and reproduce my issue. And going back to reproduce my issue, let's go to the browser. There it is. I'll click on the select button, and here, because I turned this exception on to break when thrown, I'm seeing this exception helper pop up. This exception helper is a new style that we added to Visual Studio 2017. It's convenient in the sense that it shows you just the information that you care about. It'll show you the exception type and its corresponding message. And a new thing we added for null reference exceptions in 2017 is that it'll tell you what specifically returned null. So in this case, it looks like name returned null. And I can verify that on a simple hover down here where driver.name is actually null. So without even looking at my code, I was able to use this exception helper to get insights into what was happening. So if you're used to ignoring the information that the debugger presents to you, I encourage you to go back and look at this stuff again. There could be helpful information buried in there that you may not have seen before. Okay, so now to solving the issue of why exactly name is null. To do that, I'm going to go to the immediate window. I love using the immediate window as a playground of sorts to help me manipulate variables, run through link expressions and lambda expressions, figure out what to do next, essentially. So just wanting to verify before I go to my playground that the exception thrown is actually caught. So I'll go ahead and step over, and indeed it lands in my catch block. So let's investigate this piece of code in the immediate window. And if I hit enter, it would throw a bunch of exception information. But as I'm talking through this, I'm realizing I shouldn't probably be using name as the matching case here. Names can come and go, but IDs are forever. So I'm going to use the ID instead. And I'm doing this manipulation in the immediate window because I can test it out real quick. Will changing name to ID actually fix my issue? And when I execute this, I can see that I no longer get an exception, but I get an actual piece of information out of here. So I've identified that fixing this code in that way will result in what I want to happen. So now I have to go back and actually edit my code. My least favorite thing in the debugger is restarting the debugger. So any tool that will help me avoid those cycles of stopping and starting the debugger is a welcome feature for me. One of my favorites is I'm going to want this code to run again after I edit it. So one of my favorite features is being able to right-click on a line of code and set the next statement. Its shortcut key is Control-Shift-F10. And when I set the next statement, it moves my execution pointer to that line, so the yellow arrow. It doesn't execute any code. All it does is tell the debugger, hey, next time I take a step, next time I push go, this right here is what I want you to execute next. So I'm going to go ahead and set that up before making my edit. And one of the other things, so I told you could right-click on the line of code to set next statement. What you can also do is you might see this little green arrow over here. We'll talk about the green arrow in a minute. First, I want to talk about what happens when you hold the control key. So when I hold the control key, this actually becomes a yellow set next statement arrow. So I can hover over different lines of my code and click to set next statement. I find this a lot more convenient than trying to right-click or use the shortcut key, especially when I'm just needing to find this exact place in my code. So I encourage you to try that out, new in 2017, holding the control key to set next statement on the line. Now I'm going to come in here and make my edit. I want the ID, and I want the driver ID here. Okay, so now I've made that edit, and again, I'm going to point out I didn't stop the debugger. I'm using a feature of the debugger called Edit and Continue that allows me to edit code on the fly without restarting the debug session. And then I'll hit Continue, as the name implies. And look at that. You finally see my smiling face instead of a dummy picture. And let's see. Yeah, it works for everybody. And I can see in IntelliTrace that exception events are no longer happening when I click on picture after picture. But actually, something weird is happening when I click on picture after picture. And because, again, I have that diagnostic tools window open, that's what I'm cluing in on here. So when I go down here and I look at this, when I click on a button, on my CPU track, a little CPU activity is happening. And it's happening again. And also, I'm noticing when I refresh this, it's taking a little while to load. I see those ... dots coming across the screen. Well, I want to perform an app, and I want to nip that in the bud. So I'm going to go investigate why that's happening. So let's go figure out a performance issue while I'm debugging. Okay, so that's where I just made my edit. And up here in the driver method, I don't know where to start necessarily, so I'm going to start here. I'm going to set a breakpoint, hit this breakpoint, and then take a step. So because I'm interested in the performance of this application, I'm going to come here and look at the perf tips. So perf tips appear directly to the right of the line of code after you take a step or run from breakpoint to breakpoint. This is an order of approximation number to tell you how long, approximately, it took to execute that particular line of code. So if I step over again, it says less than equal 1 millisecond. So that isn't where a performance issue might be happening. When I step over this line of code, it says, oh, almost a second elapsed. So as I'm just stepping through this application and cluing in on this number, I'm starting to think maybe individual driver cached could be my issue. And then, like I said, it doesn't just work over stepping. You can run from breakpoint to breakpoint. And in this case, instead of restarting and doing this method again, I'm going to use that control click to set next statement. And now I'm going to use that green arrow. This green arrow is called run to click. You may have experienced before where you can right click, choose run to cursor, or push control F10. Sometimes that's just cumbersome to do, and especially now you can do point and click debugging. So I want to run to the end of this just to time the whole function. I could set another breakpoint, but I don't have to. So I can just click run execution to here, and it'll run all of that code and tell me approximately how much time elapsed. And because it's so easy to point and click debug, I could do that over and over again to get different samplings of the different timings that are happening. So okay, but I remember when I stepped over get individual driver cached, it was some number, and it was kind of a big number. How do I get that history of the perf tip back once it's gone? The answer is the diagnostic tools window, like the answers to most of our problems in this part of my session. Over here in the Diagnostic Tools window, you can see that it has a duration column in the Events tab. This duration is essentially the record of the perf tip that appeared on that line of code. So for example, 976. Yeah, on this step, that step took 976 milliseconds. So I can use the events, the duration column in the Events tab to record a history of my perf tips if I ever need to go back and inspect what those were at some point in time. Since we're doing a performance issue, and the other thing I noticed was that in the CPU usage graph down here at the bottom, here, let's go back live debugging. So I hit continue, I'm live debugging again. Maybe I can make this smaller so you can see more of the graph. There we go. Okay, in the CPU usage, I can see when I push select, let me reset the view here so I'm getting stuff that's live. When I push select and it's thinking, and it's still thinking. Oh, it's because I stopped at this breakpoint. Sorry about that. So let's go ahead and remove that breakpoint too. And now it thought. So I see this bump in the CPU usage graph, and I see it every time I click a button. We're doing some calculation here. I don't think that looks right, so we're going to go investigate. Back to that summary tab, we do have an item for CPU usage. You can turn on record CPU profiling, which I'm going to do by clicking that, and it takes me over to the CPU usage tab. And now when I click any button or perform an action, the CPU sampling is being taken in my application. The reason I had to turn that on is so it could be more pay for play. You know, we don't want to we want to make your debugging experience as fast as possible, and we only want you to pay any performance cost when you're actually using that feature or trying to investigate. So as I'm trying to investigate this, I want that CPU usage turned on. Okay, so now that I have a little bit of some samples to go investigate, I'm going to have to break all, which just means that, hey, I'm going to pause the application, I'm going to let the CPU usage data be prepared, and it's going to show up in the CPU usage tab. Okay, so in this tab, I now see a flat function view of my CPU usage, and it's showing me where the majority of the time is being spent. So I'm going to start here at the top where the majority of time is being spent. When I click on this, it's going to open up a CPU usage view. In this view, I have a butterfly chart up here. It's called a butterfly chart because you can see here's the function body and here are the wings, the calling functions and the called functions. I can also navigate through this chart. So I'm in this function body right now, but what else does it call? What else does it call out to? And I can click on those things to get those different, to navigate to those different parts of the code. And in this bottom panel, I can see those. In this bottom panel, I can see that code here. Now this is just a viewing pane. I am not going to be able to edit or set breakpoints in here right now. But what I can do is I can go and click on this link that'll take me to that place in code where I could then go investigate and edit that point in code. So let's look at this again. Okay, and we'll go back to that point in code. And so possibly get driver list is an issue that I'm having. Oh, and here it is in the function. Okay, sorry folks, I confused myself a little bit as I was clicking around. Get driver list could be responsible, so I'm going to navigate to it in my code, and here it is. So now that I'm in get driver list, I can investigate, what's happening here. Let's set a breakpoint and get back to this breakpoint. I click on the driver, the breakpoint will be hit. And now that the breakpoint is hit, I'm going to just step through using those perf tips again, or even run to cursor. Let's see. oh, in that case, driver string wasn't null, so I clicked in a place that I probably shouldn't have. So let's hit that breakpoint again. And let's go ahead and come to the bottom of this function. Okay, so I'm down here, and then when I step over here, that's where a lot of time is happening. So it's in this deserialize object call. Since I'm trying to cache these things, I probably only need to do that one time. So what I'm going to do is uncomment out this part, and I'm going to do the deserializing up here, and then I'm going to return the cache drivers. I'm going to return my cache drivers. And I've run into some sort of issue. We're going to hit continue and see what happens. Okay. I normally don't like to restart debugging, but I'm going to go ahead and do it in this case. It looks like I made an edit that was causing a build error, so let me go look at this again. So now I'm just looking at this, and I'm supposed to be returning drivers, but I'm not. So I must have commented out something that oh gosh, that's why it's having an issue. I'm supposed to comment out this line too, because I'm returning mcrash drivers. Sorry guys, sometimes it's hard to debug on the fly and debug your own code. Okay, so now when I start, I shouldn't have an issue anymore. It's going to build. We're going to keep looking at the CPU chart. My driver's going to load. Now I'm going to click it. And every time I click it, if I'm looking over here at the CPU chart, no more CPU is spinning up. So I kind of use the diagnostic tools window to verify that I'm no longer getting those spikes in CPU up here. So that was really great for me. Now that I finished that performance issue, I can turn off recording of my CPU profiling until I perhaps see another CPU issue occurring. And I like to go back to my summary tab. Since we're still in the diagnostic tools window and I haven't showed you that last thing, I've been monitoring that process memory graph just kind of out of the side of my eye. And again, something is really happening with these button clicks. Let me tell you, just all of the issues. So when I'm clicking on this button, every time I'm starting to see this process memory just increase and increase. So like every time I click on the button, it keeps going up. That's kind of perplexing to me. I don't think that should be happening. So dun, 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 we're gonna go investigate. Because I'm looking at the process memory graph, I'm going to come and I'm gonna take a snapshot. The snapshot will take me over to the memory usage tab. And on this memory usage tab, you can see that will show you the object size and the heap size. And if I take another snapshot, which I can do right here from the toolbar, we also show you the diff between those two snapshots that we took. So when do I see my memory start to tick up? I see it start to tick up when I push this button. So I'm going to push this button a couple times and then go take another snapshot. Okay. And in that case, I saw that my memory went down, but that could be because, oh look, I see this yellow tab here that told me a garbage collection occurred. So that might be perplexing to me, but now I have this little indicator, this little yellow bubble that tells me a garbage collection happened. So I'm going to ignore that snapshot and I'm going to try to take another one. Oh, but I need to reproduce my issue. So I'm going to click this a couple times and then take another snapshot. Okay, this time I can see that a garbage collection did not occur and my memory increased. So I'm going to go ahead and click on this diff. That's going to proceed to open up a snapshot view for me. And I'm actually going to take a look at this one. So I'm seeing here that my driver has a lot of objects on it, and I'm going to go investigate. Okay, it's my driver cache, home controller im driver cache. So let's go find that. Home controller. Whoops, okay, I'm typing im driver cache. There it is. Okay. So my memory tool clued me in to this maybe being something that's causing my memory to increase. Now I want to go investigate this driver cache. So I could F12 to go here, but this is something I just found out about. I'm using Visual Studio 2017 Preview 3, actually. When I hit Control click is basically go to definition, and it takes me to that point in code. So that was really easy for me to get here to my driver cache class, and makes it easy for me to investigate what's happening. I'm going to go ahead and make the diagnostic tools window smaller again. Just real easy right there. It shows me I have 5 snapshots that I've taken, and I can get back to those anytime. Now it's time for me to figure out, I've pinpointed the location of where my memory issue may be occurring, so now it's time for me to figure out, well, what went wrong? I'm going to do this. I don't know if you noticed, but I have something called debug.writeline in a lot of my code, but I don't actually have any of that here. Debug.writeline is basically like the printf of debugging, and that'll show up in my output window and in my events tab, kind of like logging. I don't have those here. I don't want to necessarily hard edit my code to add them. So what I'm going to do is actually add what we call a trace point. So this trace point starts, how is a trace point born? Well, it starts as a breakpoint. I'm going to set a breakpoint on this line of code, and you'll notice that this little toolbar appears next to the breakpoint. So I can click this settings gear to open the breakpoint settings. We have breakpoint conditions and breakpoint actions that you can apply to any breakpoint. We have 3 types of conditions. There's a conditional expression. You can apply a hit count. You can also apply a filter. Conditional expression is exactly what it says. If there's some condition that you only want to break when that condition is true, you can write that inside your conditional expression box. And we actually have IntelliSense that appears here now for you. So if I wanted to have a condition, when key is something, I can put that in here. The other condition we have is hit count condition. So for example, if I'm in a big loop and I'm iterating through, 100, 200, 300 iterations of that loop, and I know that it's only on the 105th time that something bad happens, I can write a hit count condition of 105. And now this breakpoint will only stop on the 105th iteration. The last type of breakpoint you can put here is a filter breakpoint. We make it easy to filter by thread or process or machine name. So that's what you can do here, machine name, process, or thread. That's great when you're needing to do multi-threaded debugging and only hitting breakpoints with certain thread IDs. But why did I really come here? I came here to show you how a trace point is born. Well, it's born out of the actions checkbox. We have one action, which is log a message to the output window. And in this message, I can put 3 different things. I can put plain text. So here we're adding a driver. So if I write plain text, it'll be printed. And which driver am I adding? Well, I actually want the key to tell me which driver, like what the key is of the driver that I'm adding. So I can type in key here, and then between these curly braces, that will actually print the value of key. And the last thing I can put here is I can use a $sign to access these rich pseudo variables that we have for you while debugging. You can, use the function name, for example, here, because add driver to cache will be printed here. What makes this a trace point is the fact that it says continue execution. So this box is checked by default. What happens when this line gets touched in the code is that it's not going to break, but it's going to print this message and then continue. So it's not a breakpoint in that sense. I wanted to add a trace point for adding to the cache, and I want to add a trace point when we're getting a driver from the cache, and then I'm going to go investigate this. Like I said, I could use that settings bar, but if I know exactly what I want, I can right-click on this breakpoint and choose Actions, which opens this up with that automatically checked. And I'm going to type in here, getting driver, and then the key, and the function. Okay, great. So now I hit enter, it's saved, I can close this, really easy and lightweight. Okay, now that I have my trace points set, let's run this so it hits those trace points and see what happens. So again, I'm investigating that memory issue. I am clicking around on the different drivers, third driver just for fun. Now let's go back and look at this. So as I was clicking, events were being added to the diagnostic tools window in the events tab. I can see that there are trace point events that are getting added. This program output is that debug write line that I mentioned earlier, but the trace points are something unique. They're transient. I can, add these to my code without changing the code itself, which can be really convenient. But I don't want to look at that program output. I kind of just want the trace points that I just added. So I'm going to use search and filter to just trace points. And now that I see this in the events viewer this way, I'm cluing into something weird is happening because I'm getting a driver and adding a driver and getting a driver and adding a driver. If this truly is a cache, I would imagine I wouldn't be adding drivers this much. I should be getting them mostly, right? Well, let's go take a look at that string here, the key that I added. So when I go and look at this key, I can see that it has an ID, a name, a sequence. Okay, let's just go look at the key in the code. So I'm going to turn this trace point quickly into a real breakpoint without losing any of the information that I've added there. And I'm going to hit that breakpoint by triggering one of those actions. Okay, so now I'm adding a driver to the cache. This should already be in the cache because I've clicked that button before. Let's go look at this key. On my key here, I can see that it has ID, name, sequence number. This is a little hard for me to parse out, actually. I mean, in this case, it's kind of easy, but imagine that I have a string that's formatted a lot more complicated. I can use this visualizer here, and we have several visualizers, text, XML, HTML, but I'm going to use JSON. And when I go to look at this, all of a sudden I can breathe a little easier without all the slashes and quotation marks in my way, because I can easily see, ID is 1, name is blank here, but I do have a sequence number, which is a little strange because it looks like that sequence number, if I go back to my IntelliTrace, it looks like that sequence number is changing every time. So like here it's 25, it was 24 before, so it looks like that sequence number just keeps going up. I showed you that key in the JSON visualizer, and I showed it to you here, but imagine you want a more permanent solution where you don't have to open the window, the JSON visualizer every time to kind of see the string in a prettier manner. One fun secret is that you can type the variable in the watch window here, right? And it'll show me the key with, the string literal version of key. So it's got escape characters. If I'm dealing with something, I did this just recently, that I really wanted to know about this, was I can add in Q after my variable, which just stands for no quotes, right? So it's going to take out all of those escape characters. And you can see right there, it now has ID is 1, name is null, sequence number is 27. So I don't have to parse that string as much, just eliminating some of the brain power there for me. So remember, comment and Q can be really helpful down in like the watch window, for example. Okay, so as with any good demo, it looks like I have my fix in here already. I'm going to turn this back into a trace point. And because I'm adding that sequence number at the end, the key based on that string alone probably isn't the right thing to do here. I should probably use my driver info or ID to be the key. So let's uncomment this line here to take out that sequencing string. That's kind of messing everything up. Now, when I hit continue, I just did edit and continue again. When I hit continue and I select these things now and I hit them over and over again, let's go back to my events tab, and you can see that it added one time, but then it's getting several times. It's getting all of the other times after that. So if I keep selecting myself, you can see that it's just getting driver over and over again. So that is one way I could use trace points and the events tab to help me figure out my issue here. Okay, let's go ahead and get rid of these breakpoints for a minute. Okay, so I think I may have hounded on the diagnostic tools window long enough. I just wanted to point out that it's super helpful when you keep it open in the background. It can really help you understand maybe things you would have missed otherwise as you're going along. So for the second part of this session, I'm just going to start the same app back up. And I was working on something where I just wanted to get a list of all the drivers that were available in my fake company, right? These are actually my teammates, right? Our night job. So I'm going to go and click on the PM team here. And I was expecting to see a list of drivers, but instead I saw an exception. So that's a bummer. Here with this exception, it's a key not found exception. It's in something called file utilities. I actually haven't been touching this code. I don't care about this exception at all. I'm going to hit continue. Oh wait, there's another one and another one, system.exception all over the place. This is kind of a bummer. This is happening because I had exception settings turned on earlier that were common language runtime exceptions. So now all of these exceptions are going to break when they're thrown. I don't know if you've ever experienced this, but it can be kind of annoying. So what we did in Visual Studio 2017 is we added one checkbox that'll hopefully make your life easier. When I look at my shuttle when I look at this exception settings down here, you can see break when this exception type is thrown, except when thrown from my shuttle.settings library. So with the click of a button, I can ignore all of the rest of these exceptions that could potentially be thrown from this place in the code, in this settings library that I don't care about. One other thing to point out here is that it showed me my inner exceptions right away. So that's another new feature of this exception helper. Anytime you break on an exception, you're going to be, if there are inner exceptions, we'll instantly show them on the innermost exception. And so you can really get that information that you care about right up front here. So there we go. And like I said, I turned off the rest of these breaking. So now I hit continue and I have a different exception. Well, that was a system exception. This is an old reference exception, and it's in home controller, which is a file I care about. So I've avoided all other exceptions that I don't care about. I'm going to go ahead and now fix this issue. It's telling me trim driver list was null. So let's go ahead and look at my trim driver list. Oh, there it is, right up there. It's being initialized. I'm just using Control-click to navigate around here. It says initialize list. I forgot to return a new driver list. So let's go ahead and return new list with the drivers. Okay, so now hopefully I'll have to actually use control set next statement to go back here to make sure that list gets initialized. But now when I hit continue, I don't hit an exception. Actually, I don't hit an exception, but I should be seeing my drivers. One more bug to figure out. Let's quickly go figure out what's happening. And I'm going to do that by going back to this trim driver list. You know, where is this being called from? Okay, it's up here in get all drivers. Let's just step through this method. I'm going to hit that breakpoint by refreshing, and I'm going to go ahead and start stepping. Okay, oh, here's that settings library. That's where all my exceptions were being thrown. Good thing I can just step over those and not worry about it. Okay, trimmed and sort list. Now I step over that. tripped and sort list is 0. I'm expecting to see things in there. So I'm going to go look at the autos window. And a fun fact is that you can see the return values in the autos window here. So I've got multiple function calls on this line. You can see that trim driver list returned 19 here, objects in this list, but sort returned 0. I wouldn't expect that to happen. I would expect sorting a list to keep the same amount of objects in the list. Okay, so let's use trusty control-click to set next statement and come back and step into this. So I'm on this line now. Sort driver list was where the issue was happening. I'm going to right-click on this line and go to step into specific. So I'm going to step into sort driver list here. And now that I'm in my sorted driver list, I see that it's calling into ordered list. Ordered list is right here. I'm going to use run to click to go ahead and come to this line of code where this list is being ordered. Now, I think I see my issue, honestly, is that I'm not assigning ordered driver list to the result of this expression here. So that's what I need to be happening. I don't think I can spell ordered right, so let's try this again. O-R-D-E-R-E-D, ordered driver list. Okay. So I'm gonna set my next statement up here. I really love this feature, just really easy to navigate around. Okay, and so now I'm going into this. I can see that there are, my D object here. I can see that there are objects that are being gone through. So I just click the pin icon next to that data tip to pin this here in the editor itself. That's another debugging feature, and I can use to expand this to see the different objects that I have in this list. So pin data tips are super helpful if you're going through lists like this. So I can keep stepping into, and this driver keeps changing. So now it's Kenneth, and I can use my pin data tip to watch that. Now, okay, so I want to get through everything, but I especially want to show you my new sneak peek at the feature I kind of teased you about and promised you. So let's pretend I'm stepping through this list and I'm looking at my driver and I'm looking at their name. So I'll just pin that one too. I'm looking at my driver, I'm looking at their name, and I just keep stepping. Well, okay, all of a sudden I'm at this person and I want to see more information about them, like their phone number. And now, okay, this phone number looks, maybe the phone number or the ID or some part of the object you're investigating looks scary, and you want to go compare it to something you previously stepped past. Well, I didn't have the forethought to pin that object ahead of time or take down any information, for example. So what I need to do is actually step back to that point in code. So this is the new preview feature that I wanted to tell you about. It's step back. It's actually a function of IntelliTrace. So I'm going to go back to that events view, and you can see these little camera icons that are appearing on the events in the events view. When I click step back, it actually takes me back to when that information was available. So this takes me back to Dimitri. And in my locals window, I can actually investigate all of the details about Dimitri. And let's say I want to just keep stepping back. I can basically reverse this whole list that I stepped through and drill into those details and see, the depth of the object from previous times. So step back is something that is pretty amazing. So I also promised you a special guest at the end. So let me go ahead and stop debugging, which I did, and go ahead and just commit my changes so my coworker can come and show you more about production debugging. Okay, so let me go back to my slides real quick. I gave you my demo. I had a list of the features I demoed. I know we had a long time coming. Step back, what? Exactly. Soon it will be in public preview. If you want to try it first, fiddle around with it yourself, take this survey, sign up for it, and and that way you can get your hands on it first. But now I'm going to introduce my coworker, Nikhil, my special guest. Come on out, Nikhil. And I'm going to turn it over to you to show you the snapshot debugger.
Thanks, Casey. So Casey gave us a great overview of how delightful debugging locally can actually be, and she gave some great tips about how to debug in a local session. I'm going to be talking a bit about how we've made debugging possible at a cloud scale with a new feature that we're calling the snapshot debugger. And for the essence of time, I'm going to go straight into my demo and switch to the branch of my application that is actually deployed out into a production environment. So the same app that Casey was debugging locally, I have gone through and deployed it to an app service out in Azure. So I'm going to quickly go to the website where this app is hosted, and you can see it's a lot of the same. It's the app running out in Azure, out in production. And out in production, it looks like everything is working fine. However, when I click this Pontiac G8, it looks like for my particular picture, my name is loading, but my picture is not. So what I'm going to do is I'm going to use two new features in Visual Studio called snap points and log points to actually debug this issue for my app as it's running in production. To use snap points and log points, I need to attach Visual Studio to the instance of my app as it's running in production. And to do that, I can come into the Cloud Explorer. I can select out the app service where my application is running. I can right-click it and attach the snapshot debugger. Now, what this will do is Visual Studio will go through and talk to your app service and attach to it so you can debug it a lot like you can debug locally. So it'll take a second to load up. But as you can see up here, Visual Studio is now debugging an application that is running out in Azure. This looks and feels a lot like local debugging. And what I can do here is go to a particular method I'm interested in. In this case, it was on loading of a particular picture that I really care about. So I'm going to go to the get individual drivers cached. In this method, instead of setting a breakpoint in my gutter here, what I actually do is set something called a snap point. I'm going to zoom in on that so you can see. I'm going to try to zoom in on that. So this snap point, what it does is when it gets run on your server out in production, instead of stopping your application and allow you to debug state, what it'll do is it'll quickly take a snapshot of your application and allow you to analyze what's going on, but the application will keep running. Anyone who's hitting your server or hitting your site will have no idea that it's being debugged at the same time.
That's pretty cool.
Thanks. So this snap point, it doesn't turn on by default. I have to hit this Start Collection button up here to turn the snap point on. And when I do so, I get a collection started message in my diagnostic tools window. Now, any request going into my app on production, whenever that code path is hit, I get a little snapshot taken. So I'm going to go through and hit the car that was causing my image to be loaded incorrectly. And when I do so, I see a snapshot open shown in the diagnostic tools window. I can double-click this snapshot, and Visual Studio will be debugging the point in time when that particular line of code had been run. And while that debugging is happening, I can see that the site itself is still responsive. It still has all the perf fixes that Casey went through and made. It's still really spiffy and fast. And at the same time, Visual Studio is actually debugging. It can see the call stack when that snapshot was taken. You can look at your autos, you can look at your locals, and get all kinds of debug information for that particular time when I had hit that code path. So in this instance, it looks like the driver was incorrectly loading for my particular image. So I'm going to try to dig into the driver object and try to figure out what's going on. So I'm just going to hover over the driver and click through here and look at what's happening with the picture. And it looks like there is some data in this picture object, and that's weird to me because though there is data there, it looks like the picture was not correctly loaded. So basically, the problem here is it looks like while there is a picture, it looks like I don't have any kind of checking on my application to see whether the picture is correctly formatted or correctly used in my application. So maybe that's something I need to go out and fix. Now, a key thing to point out about snap points is that while requests are going into your application that can trigger a snapshot, these snapshots get taken in about 10 to 20 milliseconds before your app continues running. We've done all kinds of load testing and all kinds of analysis on the performance impact of your application. And I think it's safe to say there's a very minimal, if not no impact at all to your application to use snapshots live when your application is running itself.
That's awesome.
Thanks. So I don't have time to fully demo this feature, but snap points, like Casey showed you earlier, can have conditions and actions on them as well. Conditions allow you to conditionally take a snapshot only when certain things are true. So if a certain request has gone into your application or a certain conditional statement evaluates to true, you can take a snapshot then. Actions, what they let you do is, similarly to using a trace point in your debug session, you can take an action to create a new log message. These log messages can be used when you are looking through your logs of your application and you realize that you haven't really logged out the full details of something you want to. You can use an action here to create a new log message, which will be temporarily active while you are snapshot debugging.
Wow, that's awesome. So like I was using trace points locally to add logging, you're using log points to add logging on the fly in production environment.
Exactly.
That's really awesome.
And I don't have to edit my code, I don't have to redeploy any of that to get new log messages to try and debug what's going on.
How are people tuning in going to find out more about this?
So great question. I'm going to go back to the presentation. So snap points and log points are now in preview. You can check them out at aka.ms/snappoint, where you can learn more and get this stuff set up on your application. You require Visual Studio 15.4 Enterprise to use the snapshot debugger, but other than that, it's out and ready for you to use today.
That's fantastic. So I hope everyone, I'm glad we brought Nikhil on for the end here to really convince you to go out and try aka.ms/snappoint, and also try all the new features that I demoed from Visual Studio 2017. So with that, take care.